Welcome back. In this submodule, we're going to discuss a simple concept, which is the notion of radian. So far, our discussion of angles have all been in degrees. This is just a way of measuring angles. Right angles are 90 degrees, a straight line has 180 degrees, and 360 degrees takes me all the way around and back to where I started. But degrees are not desirable for calculus. It's not a system of measurement that is particularly convenient for the types of operations one does in calculus and other higher mathematical subjects. To get around its difficulties, a system known as radians was introduced. We're just going to discuss how to convert from degrees to radians. From this submodule on, I'm going to use them interchangeably, and you should be able to do the same. So the relationship between radians and degrees is simple. You can think of it as the same as if you were exchanging currency. 180 degrees is equal to pi radians. So instead of talking about a big number like 180, you get to talk about a small number like 3.14. That's really the only connection here. You should be able to go from radians to degrees and degrees to radians entirely based on this conversion formula. So writing it perhaps a bit more clearly, to convert from degrees to radians, one multiplies by a factor of pi over 180. To go the other way from radians to degrees, one multiplies by a factor of 180 over pi. How can you remember that it goes one way and not the other? Just think about what happens to pi radians. When you do the conversion, you ought to end up with 180 degrees. Pi times 180 over pi is 180. So that's how you want to remember this. To go from radians to degrees, you multiply by the big number. To go from degrees to radians, you multiply by the small number. So let's just have a quick exercise. Let's convert all of these degree measurements to radians by multiplying by pi over 180. So 360 times pi over 180. What is 360 over 180? 2. So this is 2 pi. How about 90 degrees? What does that convert to? Well, what's 90 over 180? 1/2. So this is pi over 2. And then 135 times pi over 180. Well, this one's a little more delicate. So 135 over 180. And what is this? Well, they're both divisible by, let's see here, 15. Right? So let's write this as 12 times 15. And then what is the top? 9 times 15. Yep, and then we cancel the 15s. So I get 9 over 12, which is 3 pi over 4. Okay, so you should be comfortable with these types of conversions. And of course, these were all done by hand. You might be asked to do less convenient numbers, which you can with your calculator on the CLEP exam. So let's just go the other way now. Let's take some radians and convert them to degrees by multiplying by 180 over pi. So pi over 3 times 180 over pi. The pi's cancel, and I get 180 over 3, so 60. 3 pi times 180 over 60 over pi. So the pi's cancel, and I get 180 times 3, which is what? 360 plus 180, so 540. And lastly, let's just look at 2. So 2 times 180 over pi is 360 over pi. And there's not necessarily anything simple we can do with that. It's some sort of very long, infinitely long decimal expansion. It doesn't come out cleanly in this case. But that's okay. It's still useful for calculations as long as you had a calculator.